for the road project, so that I could explain you what are prerequisites in the model, so that you can actually use full BIM features. What I have here as of now is actually the way most of the companies are working. So working in Civil 3D or similar software, adding their own set of classification codes, their own set of properties, and then utilizing our software based on this data as the basis. But I'm going to go through these details. So let me just first share my screen. Okay, good. Let me just start sharing my presentation. Okay, I hope you can see now my presentation. Okay, just a few words about the company at the beginning. So we are 18 years in software development at the moment, 13 years in construction management. So we started developing this software a long time ago, much longer than when it was I would say when we could sell this software to the people. So we actually started as internal software for our own construction management business until 2019. So only from 2019 onwards, we are selling software as a software vendor, since basically from then on, the market was ready for software like this. At the moment, we are present at 72 countries worldwide, on more than 6,500 projects. Which estimated value is around 350 plus billion US dollars that are managed with our project solutions. We have a range of softwares that I'm going to explain you more in detail later. What are the different softwares and how they all fit into the ecosystem of our softwares. We are a multinational member of Building Smart International. Let's say that we shift our focus from the consulting, which is still part of the business, more to helping people to integrate BIM, to implement BIM on their solutions. So trying to bring sort of digital transformation to the companies. Our clients are well-known companies from all around the world. So maybe you can see some really big names from the construction industry, from Europe, from United States, Middle East as well. Also some people from Japan and so on. So we're pretty global when it comes to the companies that are using our software solutions. Just a few words about Bexel Manager users. So the biggest part of our users are big contractors and public and private investors. So this is the main focus. They I would say find our software as the best return on investment software. We are present, from the infrastructure to you can see that railroad, bridge infrastructure, road infrastructure is a big part of the projects that is managed by our software. So we have a lot of experience regarding this as well. When it comes to the software itself, this is the general ecosystem of our software. So the main, I would say, flagship product is Bexel Manager. So that is a desktop product that has flash detection module, quantity takeoff module, cost module, so to integrate your cost classification with the model, smart 4D, 5D scheduling engine, which means that you could schedule and plan directly in Bexel Manager, track progress in Bexel Manager as well. We have model checks. That means that you can check if you populated all the data into your Civil 3D model. So if you know that, I don't know, if you're building a tunnel or a stretch of the road, you know that for every section, for every element in your model, the designers need to populate start chainage, end chainage, cost classification code, material code, area, volume, thickness, and so on. So all of these properties that you prescribed. So we have an algorithm that could automatically check within this software, that could automatically check if those properties were actually populated, if those properties are in the right type of the property, and if the values are valid. Because, you could have values in the property that are invalid. Maybe that the axis of that road should be named 010203, and then some of the designers is naming it ABCD. So that will be again identified by the software as a wrong data, and you will have a dashboard, and you will have BCF to send it back to designer to change this. So besides all of this, we have a lot of templates. We call them templates. That means that once you do your cost classification integration, on the next project, you don't have to do it again. You simply save template, and then the next team could just import the cost classification and integrate it automatically. If you're developing schedule planning, when you develop the what we call methodology for that schedule for one project, you can use it on the next project of the same type. So if you develop methodology for the bridge, you can reuse it on the next bridge. So you are saving a time with every future project by saving the template of how you were working on this project. This is also something that we call knowledge management or knowledge database, so that you can save your knowledge for the other teams to use it in the future. So besides this desktop-based, we call it expert platform. This is something that would be used by your planners, by your cost department, by your project managers. We also have a range of cloud solutions. So those are small cloud-based modules, applications, which are serving for collaboration and communication. What this means? Let's say that you have quality control manager in your team, and it needs to communicate, and he needs to send the results to the designers. He can do that very simply without need for the designer to buy Bexel Manager application. He can just get the account on your company common data environment server, Bexel CDE, and he can see the model on the cloud, and he can see exactly the data that he needs, which elements are wrong, which elements are in the clash, and so on. So you can share information through this cloud platform. This cloud platform is modular. I'm going to later maybe talk more about the platform itself. So it has a Bexel viewer, it has Bexel portfolio manager, Bexel docs. So you can also have the documentation on the cloud linked to the model, Bexel facility maintenance if you use it for the operations and maintenance phase of the project. Also, we have open API that allows you to integrate with third-party applications. So if you're using ERP system, we can, with a small add-in in a matter of weeks, we can create direct link between your ERP system and your Bexel Manager solution. Okay, so our software solution is not limited in any sense to some standardized cost classification system. So the system is completely open. If you have your own internal classification system with your own coding, that's completely fine. We can integrate it with the Bexel Manager with no problem. And if you're using the same coding system in your ERP, then connection of your ERP and our Bexel Manager is very, very easy and straightforward thing. Right now, I'm going to skip to the live demo. This is one of the sample projects which we developed with a company called CGS Labs from Slovenia. They are creating solutions for the designing the roads and infrastructure projects generally, but the approach is very similar. The basis is the same as with the Civil 3D, basically. So it's creating the generic models, which are then in their solution automatically enriched with the data. And in Civil 3D, you probably do that with the Dynamo scripts and so on. So this is the same approach, and we can even share this example with you if you want, because this is a sample project that was created exactly for the demonstration purposes. So how our software works. So this is some basic infrastructure project, railroad infrastructure project model that looks probably like any model that you have. The only prerequisite for Bexel Manager is actually that, for good implementation, I would say, is that it is modeled in a certain way. It is always good. So now I'm giving you recommendations that the model is subdivided. Let me just find some of the examples. Let's say that it's subdivided in sections. Because why? Because when you're planning your linear projects and when you're executing it, it's going to be executed in sections of 20 meters, 50 meters, 100 meters, whatever is the technology of execution. So we always recommend to the designers and to people when they start implementing BIM, okay, when you're building your model, try to cut it into sections, because then your schedules are going to be much more realistic. Because if you have stretch of the road that is 5 kilometers long, and if you say that this 5 kilometers long stretch is going to be executed in 6 months, then you don't have really good control of your schedule. So after the third month, it's going to be very hard for you to know if this is going to be really accomplished in 6 months. But if you are subdividing your linear projects into smaller pieces, then you can have, I would say, time gates. That's how we call it basically, so that you know that, okay, this one stretch of 20 meters or 50 meters has to be executed in a week or 2 weeks. So you have very clear idea if the people on site are meeting their milestones or not. And if they are not, then you can react, then you can, talk to them to see if you need enough resources, if you have enough resources, if you have enough time, you have a good planning, if you have a problem with the sequence, you can immediately react and you can immediately see where the problem is. Some of the basic information that are relevant for the infrastructure project, especially linear, is just some set of the parameters, and you can see it here. So for this specific project, it's like 15 different parameters, so nothing too big, I would say. So what is important here is that we specified element type so that we know. So this could be element type or the cost code. It doesn't matter. You just need to classify your elements, especially in the infrastructure, especially if you're using tool like Civil 3D. It is important that you have some sort of parameter that differentiates excavation, that differentiates backfilling, that differentiates, curbs, that differentiates asphalt layers, and so on. So it is always good to have system, and I guess that you have one, that differentiates different types of elements, or that differentiates to which cost group it goes. That's also okay. Maybe you could have a code 1006, that means this is the asphalt, or 1007, that means this is the excavation. That's also valid. Any approach that differentiates different, I can even show you here. So in this specific system, this is project from Slovenia, we have element types. So we know exactly which element is which element type. So we can differentiate them, and then when we do the cost integration, we can actually know, okay, these elements are the asphalt layers, these elements are backfilling, these elements are traffic lights, and so on. So that is the first set of information that need to be in the project for the good coordination. So to classify your elements, doesn't matter what the classification system is. It could be completely, like in this case, completely internal, specific for that market. So there's no limitation in that terms. The other set of properties are, of course, quantity properties. So you have to make sure that you have the proper quantity for calculating that specific type of element. So if it's an asphalt, you probably need area, because without area, it makes no sense. Maybe in some case you need also volume. If it's concrete, then you almost certainly need volume. If it's a curb, you need length. So you need to make sure that all those types of elements, specific types of elements, have the proper quantity calculating property. Another important thing is axis. So that's also important in the linear projects, if we want to manage them properly in BIM, that you differentiate different axes of your project. So in this specific case, those are axis A, B, C, D. It could be, I don't know, main highway axis. Then you have some access roads. Then you have some railway line that goes across. So it doesn't matter. It is important that you differentiate different axes on your project so that you can even plan them as separate axes, because you're going to probably attack them in a certain sequence. And the third very important part is chainage. Chainage system means that every element on your axis has chainage. We call that stationage in this part of the Europe. So we use more a French word. English call them chainage. I'm not sure how you call it in your part of Europe, but that is basically just the number that says that this element starts plus 200 meters from the beginning of the axis and it ends plus 250 meters from the beginning of the axis. And with this set of data, we can ensure that integration of the cost, integration of the schedule, progress, or anything in BIM with our solution is very easy. So in this specific project, what we did in this specific sample project, we got the model that has all of this data. We got the cost classification. I'm going to show you how it looks like in this. So it's completely custom cost classification. So it's not standardized system. It's some unique system that this specific company uses in Slovenia. So their coding their naming and descriptions, their quantity formulas, so they specify everything. They deliver this in the Excel format, and it could be very easily integrated in our system. So I can, in every moment in Bexel Manager, you can export and import cost classification into the Excel. Let me just show you how it looks like. If I do this live, so let me just open it. Okay, this is how the Excel, how the cost classification in Bexel Manager looks like. So basically, any cost classification that you're using, we can simply just reorganize it to be machine readable for our software. That means that, okay, the code is going to be in the D column, the name is going to be in the E column, description in F, daily output in H, and so on, unit price in certain parts of the cost class. So we just reorganize it, reassemble it in order to be readable in our system, and then we import it in Bexel Manager, and it could be connected to the model. How it is connected to the model? It's a very simple process where you simply specify which elements are eligible for that specific cost item. So this could be as simple as, let's say, if you classify your elements by codes, so you know that elements that are excavation of binder soil, you can just select those elements and add property that is called cost code, and it could be 10001. And then our rule is going to be just simply find me the elements where the property code is equal 10001. Or in this specific case, in this project, we got from the from the people who actually developed the model a table that says, okay, for the 10001, we need element type to be ditch excavation and material to be gravel. So if you find the element with the combination of properties, element type is ditch excavation and material is gravel, then it should go to the cost item called excavation of binder soil. So this rule is very simple. It's very simple to assemble in Excel or directly in Bexel Manager, just simply using the functionality where you say, okay, just find me another property value. I don't know where the property value element type equals or starts with or contains or begins with or ends with certain value, and I can very simply filter out the elements that are eligible for every specific cost item. That's one part. Another part is when I identify which elements go to that cost item, how I'm going to calculate it. So I can create a formula. So that formula could be just volume, like in the case of this excavation. So just calculate the excavation volume. That's logical. Or calculated surface area for that specific area, or it could be area, or it could be length, or I don't know, manual excavation around the cable. So it is calculated by length of excavation around that cable, and it is paid like that. So or it could be complex. It could be volume plus 0.05 or 5% for the waste factor, or for the expansion of that excavation, or whatever is actually used in your rules for quantity calculations could be applied here. Again, the implementation is very simple. In every moment, you just use user interface, where you're just specifying things, where you just use the volume, then multiply it with, for example, for 0.05, you can just simply multiply it. Let's say, oh, actually 1.05, sorry. If you want, let's say, expansion factor for the excavation or something like that, that could be easily added like this. So it is very intuitive. It is very intuitive for engineers in the first place. And the great thing that I like about cost integration is that you can always export in this to Excel and then import it back. So you can change it in Excel. You can see it right now. If I export this again, you can see that this change is already there, that this change in the quantity formula. Let me just open it. This new Excel. Yes, it's here. You can see that for that cost classification, I changed the quantity formula. It's already changed. And if I change it in the next one, here in the let's say, multiply it with 1.1, for example, and just save this, and then import back to Bexel Manager. Sorry, not this model. And if I just import this back to Bexel Manager, import cost classification, I go to desktop and find this example that I just changed. He just override the quantity formula. So everything you see here could be changed in Excel and imported back to Bexel Manager. It's very easy to change it. And I would say that engineers are very used to this system. You know, it's easier for them to do something in Excel, import it back, than to go and to do it inside the software in some cases. In some cases, it's easier to do it in software. So this is how you import your classification system. So you specify here your unit cost, you specify here your quantity unit, quantity formula, element, query. Then you simply auto-assign this to your model. This means that when you auto-assign it, the system will go through your model. He will find the elements based on these rules that should go to every group of works. He's going to multiply, calculate their quantity, multiply it with their cost, and he's going to create the budget. And you're going to get the budget like here. And this is the simple example where we don't work with the resources. I'm going to show you an example that is not from the infrastructure, but again, it's the similar system where you have ability. If you go to the cost editor and you find the uniformat, I'm going to go where you have ability to assign resources directly. So this could be done in infrastructure, high rise, doesn't matter. I'm just showing you the sample that I'm allowed to show, where you can calculate the price of your cost items by simply specifying the price of your resources.
Just would like to add, in order there will be
Sure.
So the first way you show, it means that those prices you are just calculating, including everything, and you just set price per quantity. And here it's more detailed planning. It means resource based,
Exactly.
labor, machinery, and so on, so on. So there are
Exactly.
two options of detailing, let's say.
Yes, I would say there are three options, because you see the first system, we just use the simple system where we said the unit price is 12 for the cubic meter. But let's say that I don't have detailed resources list and detailed prices, but I know exactly from these $12 or euros how much I pay for material, how much I pay for labor, how much I pay for equipment, or how much I pay for subcontractor, because you have very different scenarios. If you're an investor especially, you have situation where you are buying material and you're paying subcontractor to deliver, to actually construct it. So you don't have labor or equipment. That's not your cost. You have material cost and you have subcontractor cost. But in some cases, maybe you know that, for 1 cubic meter of excavation, you're gonna, you don't have here material at all in that specific case, but you're gonna pay labor, 30 euros per cubic meter. You're gonna pay equipment $0.5 per cubic meter, or whatever you calculate. That's also one of the approaches. That this is between what you said, price per quantity and price by resources. This is price per supplement, when you don't have detailed idea about the resources, but you have idea which percentage of your unit cost goes to materials, which one to labor, which one to equipment, and which one to subcontract. So then you would just simply create your resources list, add the specify, this is the labor resource, this is the equipment resource. You have coding for those resources as well. And then in your cost classification, for every cost item, this is budget. So if you go to cost classification and go to any cost item, you can simply add the resources from your resource list, and you can specify, for 1 cubic meter of excavation, I'm using 0.5 hours of work of my common building labor. I'm using 0.15 hours of work of the supervisor. I'm using, half an hour of work of the excavator. I know the prices of these. I can add the waste factor as well, because maybe I'm wasting some time and so on. And then your unit price in that case is calculated directly based on your resources. And whenever you change the price in your resources list, the price will be recalculated for the cost of the cost items as well. So the costs are directly calculated from the resources there. And when you create your budget, you can see exactly which part of that cost item and overall budget goes to material cost, equipment, other costs, subcontractor, and so on, based on the resources that you specify. So that is very important. And those resources are going to be visible also in the schedule, which is very important thing as well. So let me just go, okay, to this actual schedule, task report. Okay, you see, of course, the cash flow, you see the cumulative cost, so you see the money, but you're going to also be able to see resources. So you're going to see, let's say, if you go and check, I don't know, carpenters, you want to see how many carpenters you're going to use with this schedule every day of your construction. So you see that this is not optimal use for this specific project. So you're going from 1 to 1.5, then you jump to 2.5, then you again go to 1, and so on. So obviously this was not very good schedule in this specific example because your resources were not leveled. What is also a great thing about our software is that we have resource leveling. So you have ability to say that, I don't know, maybe you have 3 excavators that could work 12 hours a day. That's the amount of hours that you could have because you have, I don't know, 2 people working in 2 shifts and so on. And you could create your schedule. And in order to determine realistic duration, you can just say, okay, I'm going to select the tasks for the excavation, for the site preparation. And I'm going to say that for these tasks, I could limit daily output to 12 hours of excavator, and he's going to extend duration based on the quantity of excavation from the model and the available resources you have. So you could have very detailed idea what you can achieve with the resources you have, and also vice versa, you could have very detailed idea if you were using your resources with the maximum capacity. So you can see that, I don't know, in the last 2 months, the excavator was working only 4 hours a day. So you were basically paying for the, let's say, excavator every day and just using it 50% of the time. So, all of these things are visible when you work in this integrated way. Again, there's no limit in terms if it's infrastructure or high-rise project. The cost implementation system is the same, the scheduling system is the same, and you're going to be able to see both. Again, the question is only if you have this data, if you have your resources and detailed cost classification in which you specify how many resources you use for every different cost item, there's no problem to integrate it in Bexel Manager. And again, if I go back, if I export this to Excel, so the same as we did with the linear, if I go here and export to Excel, to cost classification, this specific cost classification, it just opens directly here. So I'm going to open this Excel. You're going to see that the resources could be also managed in Excel and then imported back to Bexel Manager. So for every cost item, it has specified, the resource, carpenters, common building laborers, how much time you're going to use for which daily output. So how many hours you use for which daily output, for how many cubic meters of concrete. You have your detailed resources list here, and you can change this. Maybe on the next project, you have different company delivering you concrete because it's in a different part of Lithuania. They have different prices, they have different capacities. You just go and override this, import it back to Bexel Manager, and assign it, and he will automatically change your budget. What is the main advantage of this approach? Because people always ask me, okay, but if I have to spend time to develop the cost classification, to integrate it, to assemble the rules and everything, yes, it's going to take time on the first project. After that, you simply send this, export this to go to Exchange, send it to the next project, and the people could use it right away. Also, the first time when you change anything in your project, when people send you and say, okay, we had some problems with to buy the land, so we had to reroute a little bit this axis. Instead of you going and recalculate everything manually, you're going to just update your project, simply click refresh, and he's going to automatically recalculate your complete budget, recalculate everything in the schedule, and you're going to get everything updated with a few clicks. And then with the first change, you're going to save so much time that is going to pay off already everything that you did in terms of implementation and integration of the schedule. So this is about the cost. I would also like to cover a little bit the 4D. So the part of the, once you create your cost, when you integrate the cost, creating the schedule in Bexel Manager is very easy. You have two ways. You can create your schedule in Primavera, P6, or in MS Project and import it directly. So you have ability to import from MS Project or Primavera. Yeah, if you're used to working in MS Project, you can import your schedule and then link that schedule with the model elements. So you can do that linking in some intelligent way. Let's say if you're having the codes for every element to which task it goes, then we can automatically map the elements that contain certain code with the task that contains certain code. The system is pretty similar as with the cost. That's one approach. It's harder if you do it that way, but some people prefer it that way. Another approach is to create schedule directly in Bexel Manager. And this is specific for our software only, where you're able to create what we call, maybe I'm going to share it. The best way is to share, to explain you, because I have a very good graphic for this, to explain you how the system works. Let me just, and then we're going to again return back to the to the practical example as well. But how this works, since in your model you have cost classification integrated already, so whenever you click certain element, you can see to which groups of works that element is connected. So when you click on the asphalt layer, you're gonna see exactly that this is connected to the subheading in your cost classification that is called asphalt, and then you will probably have different cost item for the asphalt of 10 centimeters, 12 centimeters, 15 centimeters. They're going to build differently, and you're going to have different resources and quantity of resources assigned to that specific cost item. When you go to the scheduling part, what you basically do in every scheduling process is you are creating spatial project organization and work sequence definition. So in this very basic example where I'm trying to explain what is behind our system, what you do is, if it is a building or multiple buildings, what you're going to do in MS Project, you're going to create parent task building 1 and building 2, and you'll create some relationship between them. You're going to say, okay, I'm going to start with building 1, then start 2 months lag, I'm going to start with building 2. Then in both of these buildings, you're going to go and create subtask for every floor. So from the ground floor all the way to the roof. Then in every floor, you're going to create phase or takt in German. So you're going to subdivide the floors in some areas of equal sizes so that you use your resources in the best way. You don't attack the complete floor at once. You just go and work, 1/3 of the floor, then another third, and so on. And that's your spatial project organization. That's what you would do in MS Project. Then you will go in every of these spatial tasks and create methodology or work sequence. So in specific high-rise project, you're going to say, I'm going to start with excavation, then I'm going to go with the foundations, then slab on grade, and so on. So you're going to create the sequence. The problem with traditional scheduling is that if you have 5 buildings, you go 5 times and create the same sequence: excavation, preparation, foundations, slab on grade. And you repeat that zillion times in a project. So what most people do, they just simplify the schedule, and you get the schedule with unrealistic long tasks that is not detailed enough. You say just, okay, second floor, building 5, MEP. And then you say you have 3 months to do that. But in such schedule, you don't know if you're going to first install the electrical lines, then the sprinkler systems, or no. So the problem with this is you get unrealistic schedule, but simply you don't have enough time to go and create 5,000 tasks. With our system, you don't have to do that. And it's the same for the infrastructure. So this is the example for the infrastructure. In our system, you're not creating the schedule itself. You are creating schedule logic. So in this specific example, this is the railway line in Slovenia. It's, I think, 12 kilometers long. And it has few sections. So it has viaduct, it has a tunnel, and it has 3 different open sections. So what we do, we just subdivided them into these sections, and we created the sequence between the sections. We're going to start with the tunnel first. Then after we complete 20% of the tunnel, we're going to start with the viaduct. After we are at the half of the viaduct, we're going to start with the open stretches of the railway. Then we subdivided those viaduct and all of these sections into subsections of, let's say, 100 meters, 50 meters, whatever is practical to us. And then for every of this subdivision, we specify sequence of work. And how we did this? We refer to our cost classification system. So if in our cost classification system, we have group of work that is called excavation, we say first we execute excavation. After excavation, finish start, we're going to execute, I don't know, piping, let's say, for the infrastructure project. So we're going to excavate the trenches, we're going to put the pipes, we're going to backfill. After that, we're going to do the base layers. After that, we're going to do the sub-base layers and compact that. After that, we're going to do the covering, asphalt covering. After that, we're going to do, I don't know, these gates. We're going to do the lighting systems. We're going to do the traffic signs. We're going to do the horizontal traffic signage as well. So this is what we do once for our project. And then we create schedule by simply combining these logics. So the schedule, how it is created, it says, okay, you told me that you want to subdivide your schedule into these 5 stretches of your railway line or your highway. Then every of these stretch, this axis, you want to subdivide into zones, changes of 50 meters or 100 meters that you're going to execute in 1 or 2 weeks. And then in every of these subzones, you want to do work in this specific sequence. So you're going to start with the excavation, then you're going to go with the installations, MEP, electrical, lighting, and so on. Then you're going to backfill it, do the base layer, do the top layer, and so on. And once you do this, the system just goes and makes a matrix. So he creates all of these tasks and subtasks that are directly connected to the budget and directly connected to the schedule and to the model, and you get your complete schedule. This is just one of the examples that we did the same thing for the FIFA World Cup stadium in Qatar, which had over 100,000 tasks and relationships. But we did this in basically a few days because we just specify zones, subzones of the stadium. We specify the technology of execution, which groups of works are executed in which order, and then he just subdivided all of this into a schedule. So in this concrete example that I'm showing you here, we created schedule in the same way. So what we did, we simply subdivided this project into axes. So we have information in Bexel Manager that this is axis A, B, C, D. And then we simply said into schedule and zoning, we specify the sequence for the axis. Let me just find it. And we said, okay, we're going to first build axis B, then axis A, axis D, axis C. That is some priority system that we specified here. Why? Because in this specific part of Slovenia, this axis B is the most dominant one. So we need to complete the work there in order to the traffic can go with no problem. Then we have the second priority axis here, and those additional are our lowest priority, and we're going to execute them later. Then what we did after that, we created chainage system. So for every of these axes, we subdivided it, into 20-meter sections. Why? Because in that way, we can organize our work into more or less equal amount of resources, equal amount of time needed to execute. So we know that, let's say, we're going to execute 20 meters of excavation in 3 days. We're going to do 20 meters of backfilling in 5 days. So we have very tight normatives. We have pretty clear idea what we need to invest in order to have this logic. If we just say we're going to execute this 1 kilometer or half a kilometer stretch of the road, we don't have very clear idea how much time it's going to need. We have some idea, we have some experience, but we cannot just follow that very easily, because what you're going to do, you're going to go to if you have just this as one stretch, you're going to select that one big stretch of the road that contains, I don't know, 5,000 cubic meters of backfilling, and you're going to say we completed 5%. Then in 1 month, you're going to say we completed 17%. How gonna you know that exactly? That's going to be dependent on the people who are assessing this in the site to tell you what they think is percentage of completion. If this is subdivided in sections, then it's easier. Then you can say, okay, it's 3rd week of the excavation. This is where we are. This is where we reach. So we know exactly how much this is in terms of quantities, in terms of resources, in terms of money, and we know exactly how much time it took us to come to this specific meter of the road, and how much that impacted or pushed the other sections that need to be executed in the following weeks. So when we do this, so we subdivided this into subsections, and then what we did, we go to the zone editor. That looks like, this is like a dynamo, so this is closest to the dynamo. And for every of the axes, we specify sequence of execution. We say, okay, we're going to first execute first 20 meters, second 20 meters, and so on. So just a normal, from the beginning to the end, because this is short stretch of the road. In some bigger stretches, maybe you're going to attack that 5 kilometers in 3 places. So you're going to say, okay, I'm going to start from meter 0 to meter 200 with one team, from meter 200 to 400 with another team, and from 400 to 600 with the third team. So I'm going to start, at once in 3 locations of that stretch of the road. So you specify this. And the last part is methodology, or the sequence of work. What we did here, we simply go to our cost classification, and we said what we're going to execute first. So in this specific case, you can see removal of the traffic lights and steel lights, because there was an old road there. So we first need to remove all of these traffic lights and traffic signs and boards in order to start work. After that, we go with the excavation, So we go with the excavation, demolishing the old road, excavating. After that, we are going with the excavation for the trenches. After that, we backfill and protect the existing pipelines with concrete, Then we install the optic cables, we install the public lighting, water pipe supply. So we just specify the sequence of this work, like in any other road project, basically. And you can see, especially for the road building, the methodology is very simple. It's very linear. There are no a lot of branches. When you go with the, with the buildings, then you have, in the same time, you need to install the electrical installations, piping, sprinkler system, MEP system, supply air, ventilation, and so on. So you have a lot of branching there. Here, it's pretty clear. You just go one by one in the same area, just doing different groups of works. After you complete all of this drainage, telecommunications, and so on, you backfill the trenches. You do the bedding formation, so you backfill your base, making your basic layer for the road. You're doing retaining walls in the areas where you have to cut through the hills, underground base layers, and so on. Then you do your curbs and gates, of course, and then creation of the wear and barriers for these cut areas, installation of street lights. Construction of shoulders from crushed stones, and so on, creating the terrain and waterways, landscaping, fences, road markings, and so on. So it's that simple, basically. This is the creation of wear and barrier layer. That's basically the asphalt layer here. So why is this a good system? Because when you build the next road, you can reuse the same cost classification and you can reuse the same methodology, because you're going to build that road probably in the same way, even if it's some change, because I don't know, maybe the bedrock is different, so you're going to change some group of works. You can just do change of 20% of your scheduling logic, not the whole logic. And then what we do, so we said, okay, this is how the road is built, but here we have 5 different axes, and they are subdivided into changes. So I do the logic for building the schedule only for one axis, and he can apply it for all 4 of them. What I do then, I do a creation template where I combine all of this and say, okay, use this methodology, use this axis sequence, and use this change sequence. And then I go to my schedule editor, and I create an empty schedule, demo 02, and I just say it is connected to my budget that I've already integrated, the budget that I'm using in my company. And then I simply click Creation Wizard and load the template that I created, the template with the methodology, axis, and changes. Click OK, and he creates the schedule automatically. So you can see that it has 1,048 tasks, and it has 2,000 relationships. All of this created in a matter of seconds. Of course, duration is default at the beginning. So later you go and stretch durations or short durations for certain groups of works. But he just simply created sequence of work that we actually specified to him. And I'm going to just switch back to this one. It's the same one. And even I have ability to regroup the schedule so that I can see it by axis first, and then subdivisions, these changes, and then groups of works. And if I go to the schedule animation, so that you can see that this schedule is now not only created as a schedule, it is automatically connected to the model. So if I click animation, you can see how this specific schedule is going to be, how this road is going to be executed. So you see excavation, you see MEP lines, you see the base layer for the road, then the next axis is starting after the first one is completed with the same group of work. Then it goes the top layer, the sub base, the top layer, and of course it ends up with the traffic signs and lines and everything. And now, right now, I use the animation mode so that I can animate the camera moving. I can remove the cameras and return to the task. And it could be fixed like this. And I can go and look at it from any angle, basically. Return back. And I can see for every day of execution how this execution is going to look like. And not only that, if I go back to my schedule editor, I can see the price of this project as well, because the elements are right away connected to the model. If I go to the task report, I can see the cash flow, which is not good at the moment because everything has the same duration, so I need to optimize it. I can see my S-curve. If I had my resources, I don't have it in the moment. I can see the amount of resources, but I can see activity. I can see how many, excavation I have to do every day. All of the things are visible here. All of the quantities that need to be executed is the same for the resources. What is also great, once I do this, I can do the progress tracking. So when we start execution, I can first create what we call look ahead. So if I go to schedule animation, and if I send my animation to monthly, for instance, I can go like this and say 1 month or 2 or 3 months, and I can directly send to the people on site. So I click task, select elements completed. I can send to them exactly what is expected to be excavated, let's say the first week of the project. So they could get this, see this, go to the cost estimate, filter by element selection, and say, okay, it is expected that we excavate 489 cubic meters of this specific cost item, and that's going to cost $5,000 in this case. What they can do then, they can say, okay, but maybe we did only this. So this is what we achieved. They could go and save it in the form of document, basically, like a new selection set, progress tracking. And all of this could be done in the online application as well. I'm going to show you. So progress tracking here, and I can create new selection set from selection. Say, okay, this is actual progress, month 01. And I can send this from so I know that this has to be executed, but this is what we achieved. So I can select these elements. And and I can go to the schedule editor. I can duplicate the schedule in order to keep the baseline. So this is actual schedule. I can set up the old one as a baseline. Demo 01 is my baseline. I can compare them. So I can compare the baseline. Let me just find the none, no grouping. Okay, compare the baseline. I can see now that at the beginning, my baseline and my actual schedule are the same. Then I go to the progress. It looks like this. And I'm entering the progress. I say, okay, new progress entry is for the first month of execution. So from January 6th of 2025 to February 6th, 2025, I call it actual progress month 01. And instead of, calculating percentages or doing whatever assessment I need to do, I just go to add from selection set, and I find the selection set which my colleague sent to me. And he says those are the elements that are completed. He can tell me if those elements are 100% complete, 20% complete, and so on. I click OK. OK. Click update. My last update, or my status date, is now the February the 6th when I enter the progress. Update the schedule. And when I go back to schedule, I see that schedule is changed. This is my baseline. Because I failed to execute as it was planned, I now have impact on my progress already. And I see that impact very clearly from the beginning of the project. So whatever you do on your project, he's going to recalculate the future. What this means? This means if we said that this first stretch of the road, 20 meters, should be completed in 1 week, and we have completed only half of that, 10 meters, those 10 meters that were not completed are going to be rescheduled for the next week. When they're rescheduled for the next week, all the following works that have finished that relationship are going to be pushed ahead. So you're going to see the impact of that delay. If the next week, instead of 20 meters, we execute 40, he's going to then move the schedule back, and you're going to be, three days in advance from the baseline schedule. So the point is that with this system, you have very clear idea every moment where you are on the project, from the time wise, the schedule wise, the money wise, the resources wise. Because now when you go to the task report, you can see the difference between planned and actual. You can see actually planned and actual, and difference for every day of execution. The green is baseline, the blue is actual schedule. You see the cumulative cost. You can see how the S curves are diverging. You see a lot of these things visible already here. What is also great, once you complete all of this, you have ability to export to Power BI your all the data. So you can see planned versus actual. You can see cash flow. You can see earned value, and I can show you some examples. Let me just find this online. After this meeting, I can also send you these links so that you can find them directly. First, on our website, you have sample projects. The infrastructure sample project is here, and this is on the cloud. So you can access this as a public link. This project has more or less the same examples as the one that I'm showing you. It is just a railway project, but the logic is the same. You also can see changes. Let me just find some of these that are important to you. So let's say change code, for instance. You can see how it was subdivided in this specific example, how it has different axes. Let me just find the axis system. Infrastructure. Yes, you can see what is access road, what is federal road, what is bridge, what is railway, rails and thresholds, and so on. So all of this subdivided. You can see quantity takeoff. You can see schedule animations directly here. Let me just show you this. Sorry. You can see the animation directly in the cloud. So you can see how the schedule looks like for that specific example. So everything that I did in the Bexel Manager could be uploaded to the cloud and shared with the people like this. And this is also public. This is link that you can access and play around with this model. Why this model is good, why it is very nice to have this model in the cloud. Not only that you can show this to your investor, you can share this with the other participants of the project, so that they can see this and they can send you back the information from the project site. Okay, this is the actual project and so on. They could save the same data as I did in the Bexel Manager, but this model could be integrated with the Power BI reports like this. And this report is actually directly exported. Sorry, let me just find this example that I showed you. Directly exported from here. So this is planned versus actual template that you simply export to Power BI, and you get this dashboard. So you simply say, okay, connect this to that specific project in the cloud, use our elements, use this specific actual schedule, let's say, use these custom breakdowns, and just export this as a Power BI report to the cloud. It will take some time, of course, because it has a lot of data. Once you complete it, once you publish your report, it looks like this. So you see left and right side of your project. One is planned, another one is actual. And you can actually go month by month and see the difference between these two models. It will take some time, of course. It depends on how quick your internet is and everything. But you can actually compare, where you should be at the moment and where you are at the moment. So this is.
But it's also possible directly to compare in Bexel. I mean, visually.
Yes. Visually, yes, not with the two screens. We are developing that.
No, with in one screen.
Yes, in one screen. Yes, of course. Yes, that's no problem. And you see all of this data in Bexel as well. But these dashboards are good for reporting, because you cannot expect your boss to install Bexel Manager and to go through Bexel Manager to see what are the results of the project. You cannot expect on your weekly meeting on the construction site to open Bexel Manager and show them all of this. It's much easier that you simply export Power BI, give them the link so everybody could see left and right side. They could see the model and so on. Yeah. So this is the main purpose for the people, And you can simply see left and right. Why this Power BI is also good? Because besides this standardized report that we created, we were able also to create some specific reports for the linear projects. So this is the linear project. And in this specific case, I did this Power BI report. I tried to map deviation in terms of days between planned schedule, and actual schedule on that specific project. So I actually said, okay, where deviation was positive, where we did it, before 20 days, from 10 to 20 days before the planned schedule, it's going to be greenlit, and go to the minus 120 days where we are minus 120 days in delay from that specific project. And I even plot this to this scatter chart. Of course, right now it doesn't look really clear to you, but if I say, okay, I want the axis 100, so this should be the main line of this railway project. So I want to isolate that axis, and I want to isolate earthworks only. I can see exactly, let me just turn this off and zoom in a little bit. So I can see, for instance, soil removal groups of work. I can see exactly how it was executed directly, This simply shows from which meter to which meter of this specific railway line we were working, in which day. So I have pretty clear linear schedule for these groups of works. I can, because Gantt chart is nice, but Gantt chart is not what you need on your infrastructure project. This is more or less what you need. This is what infrastructure people in most cases understand, because this is how they actually see the project. Okay, they know exactly that, I don't know, this gabion had to be executed from this to this meter of work, or the soil removal had to be executed in this order, and then they could see if this goes to November, we are late. It has to be, in previous days. And we can map all of these different. This is just some of the examples. We have over 30 standardized dashboards and over 100 custom dashboards that you could see, and select every group of work, every subgroup of work, see exactly, okay, this cost this much, this is the quantity of that much, those are the elements that are connected to that specific cost item or to that specific axis. I can color code them and so on. What we also have in the Bexel Manager itself, so besides this Gantt chart, which could be regrouped so that you can see schedule differently. You can see the activities on the first level, or the axis on the first level, and sub-axis on the second level, and activities on the lowest level. You can also see this in the line of balance view, which is, again, very useful thing if you want to optimize your schedule in terms of continuity. If you want to make sure that your people are not idling on the construction site, if they are actually working with the maximum capacity. So let's say here I want to check the axis B. I want to select.
It's for resource optimization.
Yes, exactly for the resource optimization. But the nice thing is you can find that here and go and say find this in line of balance. He's going to select that in line of balance, and you're going to say filter selected, and you're going to just see line of balance on only one line. And if I go right click and say select elements, he's going to select me exactly which groups of works this is. And I can isolate this, and then I can find exactly activity that I want to talk about. I don't know, let's find something interesting, curbs and gates, for instance. I select this activity, select elements, isolate, those are the elements. And this is how it should be executed. Of course, this is not optimized schedule. Almost certainly in this part, I'm going to make these sections a little bit longer because it has more material simply, And I even have ability to go to specify by resources, that it calculates based on resources how long it's going to take. But you can see clearly that this is good linear sequence because you have people. It is very used in Finland. So you're more or less close to them. So they have a lot of experience in this. But trust me, I'm an architect, so I had really, really small experience with any sort of planning or Gantt chart, even not even a flow line. But with the time, when you have this in the tool, you simply start understanding the whole system, because it is logical at the end. It is a very logical system. The Gantt chart has its own advantages, but line of balance is something that is great, especially for the infrastructure, and especially those specific line charts that we created in the Power BI. That is, that is the holy grail of planning in infrastructure, where you have on one axis change, on another axis time, and you see exactly the line that goes, from left to right. That is what people who do serious planning in infrastructure understand. But of course, that will come with time. I'm just telling you that all of these are the tools that you have, that with your expertise you can utilize to the much higher level than what I did with this simple project, just to show you what could be done. You already have the invoicing automatically here. So this is actual schedule. You simply go to the schedule editor, and just a little bit. Sorry, let me just select this and go to no grouping. You simply go to export payment certificate, and you just say, okay, I want payment certificate for this month, let's say.
Okay.
I want it on daily or monthly basis, doesn't matter. Click OK. I'm going to just save it in a desktop, just for example, and you get the payment certificate automatically.
Yeah, payment request to pay.
Exactly. Yeah. Well, we here we call it interim payment certificate. So it's like an interim. It's not the final one. Yeah. In your case, it's request for payment, and it looks like this. So this is the standardized one that we created based on our experience. This could be, of course, customized for your needs. This could be specified in your language, But this is like contracted quantity, contracted price, previously accumulated, executed in certification period, total certified to date, balance to finish. And you can see, for every cost item here, exactly what was executed. This was only excavation, and you can see the numbers down there.
Good.